So this video, much of it, I just want to conceptualize what we call the orthogonal vectors or perpendicular vectors. Let's say we have the two vectors, whose angle between them it's 90 degrees, and those vectors are said to be orthogonal vectors or perpendicular vectors. Let's say this is a vector A, and let's say we have another vector and are given as the vector B. And the angle between the two vectors, let's say, is given as 90 degrees. And these vectors are said to be perpendicular if this is the case. So using the dot product of the vectors, we should have to understand that the cos theta actually corresponds to the dot product of the two vectors, which is that they divide by the product of their respective magnitudes, and that is, so this is the formula that you use to find the angle between the two vectors using the dot product. Okay, then we can be able to, let's think of cross multiplying. So using cross multiplication, we'll have the dot product of the two vectors being given as that. Now where angle theta is the angle between the two vectors. Now what if the angle between the two vectors is 90 degrees? Now we'll substitute here what is the cos 90 is given as L, and the whole of this one will be L. In this case, it means the dot product of the two vectors is given as L, and this is true for all vectors that are perpendicular. So whenever the vectors are perpendicular, the dot product is given as L, and this is only true for perpendicular vectors. Vectors that are orthogonal or perpendicular, their dot product is given as L. So this is how we can determine if the vectors are perpendicular or not. If their dot product is given as L, it means those vectors are perpendicular. And let's see how we can have this. Let's say we have these four vectors. Let's say we have a vector u that is being given as, let's say, 3i, and let's say minus j, and let's say plus 2k. Let's say that is the case, and we have a vector v, and which is given as the negative of 4j, and plus, let's say, 2k. And we have another vector, let's say, given as the w, and the vector w is given as should be I, and minus j, and that should be minus 2k. Let's say that is the case, and we have another vector, let's say, given as a vector z. Let's say it is given as, I would say, 2i, minus, let's say, I. So which pair of the vectors are orthogonal or not? Which pair of the following vectors are orthogonal or not? Let's say A. The vector the angle between the vector between should be the vector A and a vector V, and B should be the vector u versus vector W. Let's see the vector, I should say V, and actually a vector Z. So which pair corresponds to the actually orthogonal vectors? And check it and determine which pair corresponds to the orthogonal vectors. So let's say we have two vectors. Let's say we have a vector A that is given as 2, 4, let's say 1, and we have, let's say, a vector B that is given as, let's say, -3, 1, let's say 5. We should have, let's say, M. Now given that the vectors are orthogonal, find the value of M. Given that the vectors are orthogonal, find the value of M. Let's try this one as well. Let's say we have the vectors, vector X, now which is given as 2i minus 5k, should be 2i minus 5j minus 2k. And let's say we have vector I that is being given as q minus 5, 2 minus 5, that is I, plus 3q, should be j minus 5. Now given that these vectors are actually orthogonal, find the value of q. So try to look over the solution corresponding to this question and also this question as well. I want to see the responses in the comment section below. That is, if possible, but I expect that to be solvable. Thank you.